I'm going to go through the thought process that you should have when you're looking at situations for the electrolysis of molten ionic compounds. So a molten ionic compound is any ionic compound, so you should be thinking of things like sodium chloride, metal, non-metal, maybe magnesium fluoride, lithium, bromide, all metals, non-metals, all in the liquid state. They've all been melted. Okay, so sodium chloride, that's salt. That's a salt that you put on your food. All right, so imagine that's been melted down into a liquid, and we're going to put 2 electrodes into it and try and separate the ions from each other. That's what we're doing when we're talking about the electrolysis of molten ionic compounds. So the way that this works is, so we start off with the electrolysis of the molten ionic compound. All right, and the first thing you have to do is identify the ions in the compound. All right, so let's imagine we're doing NaCl, just for example. So we're doing the electrolysis of molten sodium chloride. So the first step in that process would be to identify the ions, which are going to be, well, sodium is in group 1, so it's Na+, and chlorine is in group 7, so it will be Cl-. So that's our first step. Now, the next step is to decide between which ions go to the cathode and which ions go to the anode. And you'll remember that the anode, that's the positive one, and the cathode is the negative electrode. So I need to decide which of my ions are going to go to the cathode, which to the anode. So over here, which ion is going to go to the negative cathode? Well, that's going to be my positive ion, so it will be Na+, goes to cathode. And which ion goes to my positive electrode, my anode? That's going to be my negative ion, so that would be my chloride ion, so Cl- goes to anode. Okay, now the final decision you have to make is what happens once these ions get to the electrode. All right, so what product forms? All right, so the final decision is what are the products? Okay, and in the electrolysis of molten ionic compounds, because it's molten ionic compounds, there's only these 2 ions in there. It's always going to be the same thing. You're always going to get at the cathode the metal, and at the anode you're always going to get the non-metal. You just need to decide what those things actually look like. So at the cathode, the metal forms. All right, and the metal is going to be, well, I've got a sodium ion here, so I'm going to get sodium metal. And at the anode, my non-metal forms. My ion is my chloride ion, so the non-metal is going to be Cl2. Okay, chlorine gas. Okay, now we can also add on here that the sodium metal is going to form from my sodium ion, so it's going to be Na+ is going to give me my Na, and it must do that by adding an electron. Okay, which makes sense because it's gone to the cathode, which is the negative electrode, which is going to give it an electron. So it gives it that electron and it forms the metal. Over here, my chloride ion, Cl-, forms my chlorine gas, Cl2. So how does that happen? Well, for a start, I've got 2 chlorines, so I need to have 2 here. And in order to go from 2Cl minus to Cl2, I'm going to need to lose 2 electrons. Okay, so this is negative, this is neutral, so this must have lost 2 electrons. Which makes sense because it's at the anode, which is positive, so it's giving its electrons to the anode. Okay, and then you can look at in terms of the electrolysis diagram. Okay, so this is the positive electrode, this is the negative electrode. Okay, now in here, this is my molten sodium chloride, so there's going to be Na plus ions and Cl minus ions. All right, now that's all that's in there. There's nothing else in there. There's no water in there or anything. So all of the particles in here that I haven't drawn, all of them, they are all either Na plus ions or Cl minus ions. And then you just need to decide which one they go to. Well, the positive one goes to the negative electrode, the negative one goes to the positive electrode. Okay, and then we have here, it's going to be Na plus plus E minus forms Na. And here I've got Cl minus, well, it's going to the positive electrode, so it's going to give its electrons away. Goes to Cl2 plus 2E minus. All right, now you should always have this picture in your mind of what's happening. So whichever way is easiest for you, you can think about it in terms of this picture, or you can think about it in terms of making these decisions. It's up to you. All right. Now, the work that I'd like you to do is on these 2 sheets. So I'm just going to quickly go through a few of the questions on these sheets so you know how to answer these questions. All right. Now, if you aren't sure about the explanation that I've just gone through on here, pause the video or rewind it. All right, and you can make some notes yourself and make sure you've got this idea and this diagram clear in your mind before moving on. It's not okay to just watch the video and think, yeah, that's fine, I get that. You need to really think about it, pause it, make some notes, all right? And then I want you to do this question sheet. So, question number 1. Write balanced half equations for the following reactions which take place at electrodes in electrolysis. So I've got here Ag plus, so silver plus goes to silver. Now, how can silver ions end up as silver atoms? Well, it must go from a positive ion to a neutral atom. In order to do that, it must gain an electron. All right, so you need to take each of these equations and turn it into a valid half equation. All right, that's all the question's asking you. So if I do the next one for you, Al3 plus is turning into aluminium. Well, how is it going to do that? Well, this time it's a 3 plus charge, so it's going to need to gain 3 electrons in order to do that. All right, and you'll notice that for both of these, it's reduction because it's gaining an electron or gaining electrons, and they're both metals. So the metal is always reduced. Okay, the metal is always reduced. Now we have the non-metal, so I'm going to guess this is going to be oxidized. This is going to have to lose electrons. All right, so we have I minus goes to form I2. So first of all, I've got 2 iodine atoms here, so I'm going to have 2 iodide ions. All right, now to go from a negative ion to a neutral molecule, I'm going to need to lose electrons. So that's going to be plus 2E minus. It has to be 2 because I've got 2 here in front of my I minus. All right, so for those questions, for the remaining of those questions, that's all you need to do. You need to just practice balancing those half equations. Now for the next question, it's asking you to complete the table about the electrolysis of molten ionic compounds, which is what I've just gone through in this diagram here and in this decision tree here. All right, so this is how you do it. Potassium bromide. First of all, you write the formula. So the formula for potassium bromide, potassium group 1, so it's K+, bromine group 7, so it's Br minus, so it's going to be very simply KBr. Okay, now for these ones, it's not going to be as simple as that. They're not going to be in a 1-to-1 ratio. So you need to be careful about how you write the formula. All right, now to the negative electrode. All right, so I need to decide which of these is going to go to the negative electrode. Well, that's going to be my positive ion, K+. all right, which is a metal. So from up here, I remember my metals are always reduced. They always gain electrons. K plus E minus goes to K. Okay, so the product is this. It's the K, potassium metal. Okay, now at the positive electrode, that's going to be my negative ion is going to be attracted to my positive electrode. So it's going to be Br minus, all right, and that is going to form Br2 because it's a halogen, it's in group 7, that's what Br2, that's what bromine looks like, it's Br2. So I must have a 2 there, plus 2 electrons, just like I had up here with iodine. All right, there's a pattern that goes through all of this, and that's the product there that I see, bromine gas, Br2. Okay, now, question 3 is the exact same thing, but now the questions are just written out. So we're doing the electrolysis of magnesium chloride, so I've got Mg2 plus and Cl minus ions. Which ions attract to the positive electrode? Well, that's going to be my Cl minus ions. Why? Opposite charges attract. Okay, and then you just need to make the same decisions that we did up here. Okay, now for the second sheet, all right, question 1 is exactly the same as question 1 on the first sheet. Question 2 is exactly the same as question 2 on the first sheet. All right, now just because you've got a larger charge here, don't worry about that. Okay, so look, Ca2 plus Br minus, what will that look like? Well, the formula is going to need to be CaBr2, all right, because in order for this to balance, I'm going to need to have 2 bromide ions to balance the 2 plus charge of my calcium ion. All right. Now my negative electrode is going to be Ca2 plus is going to form Ca. How does it do that? Well, this time it's a 2 plus charge, so I need to add 2 electrons. My product is still going to be calcium. And then the bromine is exactly the same as it was before. All right. And then finally, what we've got here is an application of the process. So this is how it's actually used in real life. What we do is we take aluminium oxide. Aluminium oxide is Al2O3. All right, so it's got Al3 plus ions and O2 minus ions. And we do the electrolysis of this because the electrolysis is going to isolate the metal. So this is how we get aluminium. All right, you can't just dig up aluminium out of the ground. It's not how it works. What you do is you dig up the metal ore, all right, which has got the metal in it. So it's in a kind of rock. And then you extract the aluminium oxide, and then you need to separate the aluminium from the aluminium oxide by doing electrolysis. All right, but it's the exact same as before. So, you know, so here, down here, you need to write down the name of the electrodes where you can do that. The ions attracted, well, which ion is going to go to the positive electrode? The negative ion. Which ion is going to go to the negative electrode? The positive ion. All right, so that's how you fill that table in. All right, so good luck.